afternoon, everyone. There's going to be a bit of a shift in this presentation because the focus is children. And so bear with me as I share with you what I've learned about children's knowledge on rainwater. Go ahead and start. What is the first thing that you think of when it starts to rain? Is it just clouds, maybe a hot cup of tea or coffee? Is it a picture of children playing out in the puddles, or could it be rainwater quality? Join me as I share with you the journey of a raindrop through the eyes of an engineer, scientist, chemist, and more importantly, a child. So perhaps as an engineer would ask questions related to what tools can I use to measure the rainfall, to assess the risk of a capacity when constructing, let's say, a dam. Whereas a scientist may ask a question more in the area of, well, what does that raindrop come into contact on its way down, and perhaps the roof or the cistern where we're collecting that water. But a chemist might think, well, what is the composition of that raindrop? Can I identify those components and at what levels? And so today we're here to see, what about a child? What do they think of rainwater and when it rains? And so why rained? Today you've heard 3 talks that are about water. This is the 4th one, and it's because we are in a global water shortage. The water scarcity today, as Nupur mentioned, 1/3 of over 800 million people, that's 1 out of 9 people lack access to clean water, and every year, nearly 300,000 children under the age of 5 die due to waterborne illnesses. So water scarcity is not limited to arid climates like Tucson, but to non-arid climates where stable supply is there, but the infrastructure is not there. The World Health Organization estimates that 1/3 of the world's population suffers from severe water stress, and this is expected to double by 2025, which is only 5 years from today. Yes, so what is a possible solution? Well, maybe harvesting rainwater. And when we think of harvesting rainwater, perhaps we here in North America can think of, something like a gutter in our rooftops. But the sad reality is that it could be collected in just a type of some mechanism like this, where it's just collected on a basin. So what are possible rainwater uses? Well, there are plenty. For example, it could use for agriculture or watering of green spaces. But in areas where there's water stress, this rainwater could be a source of drinking. And if some of us will have to resource to drinking rainwater, well, perhaps an important question to ask is, what is the quality of this rainwater? And today I'll talk to you about some type of contamination, microbial, organic, and inorganic types of contamination. Before that, maybe we can maybe briefly go through raindrop formation as the heat. I'm sure you all know this, but as the sun ray hits the surface of the ocean, there's a transition between gas, liquid to gas phase, the vapor rises, and at the right temperature, the moisture is visible, creating droplets that form clouds. As the clouds travel, these droplets combine, and when they're heavy enough, they fall. And as they fall, they are introduced into rivers that eventually are fed back into the ocean. And so this is a clear circular cycle, and important because the possible sources of rainwater pollution, which include dust from degradation of man-made materials, maybe exhaust from automobiles, airplanes, and power plants, agriculture and other protection applications, and animal decomposition. But maybe some that we don't immediately think of are the materials used for constructions of rainwater harvesting systems, such as the roof, the types of paints and coatings, the sealants on the roof, and then the cistern itself, the plumbing of that. And so let's go back to think of focusing on children. What do children know about rainwater harvesting and the quality of this rain? And so as part of this study, we generated some questions and prompted children to answer them through illustrations. And the children, these are the questions. Why is it important to collect rainwater? How would you collect rainwater? What do you think could be in the collected water other than water? And how would you use that rain? And so this is one illustration. And that child answered, how would you collect? So this is a pretty typical setup. They have a gutter up there. They have 2 buckets. They have a hose. So they've seen roof collection, and this is an atypical illustration where they're answering 2 questions, collection, and also what do you think could be in the collected rainwater by a form of, they could use clay and sticks and bamboo, and you also need a net. So the child may not be able to identify the type of contamination, but has an idea that possibly I could remove stuff. Maybe I should filter some stuff out. And the really interesting thing about this particular illustration is they're all sustainable materials, where it's clay and bamboo, and the house is flat, but they've created with bamboo a type of catchment on top of their roof. So this one's pretty nice. Then there's also seen in the next illustration, pretty heavy rain by the size of those droplets, a lot of buckets, right? A hole at the top of the house, and that maybe a source of catchment, and a sieve, which is misspelled, but gets through the idea that it's filtering something out. And lastly, there's a last illustration, and this one particularly nice because that's a bird pooping. Sorry about that. Yes, but so the importance here, it's right on top of that cistern. There's 2 buckets. There's a larger cistern. The bird is doing that directly on top of the cistern. Also 3 birds on the house on the roof. And this child has also identified exhaust contamination that could go and rise to clouds. So this one answers 2 out of the questions. And so just from these illustrations or from children who do not practice rainwater at home, but have seen it or have heard it in school, or maybe their school does it, generally the children know how to capture it and have some idea of the quality of it or some contamination a little bit. They know a little bit about that. So the questions addressed mostly were, how would you collect it and what do you think could be in there? And then there are two that are perhaps difficult to illustrate in a drawing. Why is it important to collect rainwater? I mean, you'd imagine it's hard for a child to draw drought in their same illustration. And then how would you use the collected rainwater? If they're not collecting it at home and they haven't seen their parents, maybe they don't know how to use it. But if they would be, perhaps they would know, oh, my mom and my father use it for gardening or watering green spaces. And so very preliminary conclusions. The two unanswered questions perhaps require knowledge and evaluation in the adult world, which young children may not have at that age. They're 8, 9, and 10 is the age group of these children. But their solutions are small scale and immediately, and more importantly, they're unfettered by practicality. That girl, there's that image of the hole in the roof. Well, you know, perhaps an adult wouldn't want to put a hole in their roof because it's probably too expensive and it's just not practical. But young children are not, they don't care about that, right? And so why, just to end this, why is it the child perspective important and useful? Well, unprecedented change is necessary today to mitigate water stress projections, such as the World Health Organization's projection of 2/3 of the population will be experiencing severe water stress by 2025. And it might be a child's innovative idea that disrupts the status quo and delivers that change that we all need. And then that's it. Short and hope nice.
It was sweet as well as short.
Oh.
Thank you. What did you learn?
I learned that children have a very good understanding when it comes to collecting rain, and that's mostly because in Tucson a lot of people are practicing this. A lot of several schools are doing this, and I was pleasantly surprised to learn that some of the children suspect that water treatment may be necessary. So the sieve or the netting, they know that perhaps we need to clean it up a little bit. So they have idea. So that was really, as an environmental engineer who has experience in water treatment, that's very nice thing to hear from a child that's 8 and 9 drawing basic filtering rainwater.
Follow up.
Okay.
But as an environmental engineer, this is not the kind of thing you would normally do with a project. So what did you learn from doing this and kind of engaging with children and other people? And you had to be empathetic and think about how they were thinking rather than just as an engineer.
Right. That's why I tried to do that, the various perspectives as an engineer.
That's what I'm asking. What did you learn? Would you do this kind of thing again?
Yes, I learned that, well, specifically, I enjoy it because being in the lab or doing engineer work or chemistry work, I don't get to interact with children on the daily, right? So I learned that I enjoy it, and I do want to continue this type of work.
That's good. Thank you.
I think everyone's hungry, right? And thank you.
Thank you all for coming. I do just want to was the conclusion of our 2019 fellowship year, and it was really great to spend time with all of these four. Our next round has also been decided, and so we have some really exciting work coming up around public health and disease in oysters, and I think Jory's is going to be working with artists to produce a documentary about this concentration discharge relationship in water management in the Little Bighorn. Another local project that's working with some people who work in a community garden and developing a cookbook, and also working in Lebanon around kind of recycling and like recycling infrastructure. So anyway, that's all starting now. So join us next year when we find out what it's